Hey, Alyssa. This is lesson 63, I believe. 62, 63. Yeah. So you got the right answer here, but you've put it in the wrong format. So when we have imaginary numbers, and that letter I represents the imaginary square root of -1, as you know, that has to go in a separate term, which is why it's separated, and it has to go second. So this is the format we're looking for. Even though you got the right number, this is an incorrect format, and it's not me. This is real math and what mathematicians decreed. So this is the way we have to answer it. You've got to put it in separate terms. So you split it, give it the same denominator because it has the same denominator. But then you've got to have that 1/10 plus or minus the square root of 59 over 10 with the I to the side. And that's how we have to do it. Sometimes you can get away with 1 over 10 plus or minus the square root of 59 I over 10. Sometimes you can get away with that, but that's not wrong, and it is technically correct, but most of them want to see the I to the side. All right, I would probably take it like this and mark it right, and that'd be fine, and I think the system will even take it like that too. But in general, when you have that imaginary term, it's always second, and the I is usually to the side. And that's the big thing. So if you'll go back and just retype that in the right format, you don't need any more explanation on how to solve it because you obviously know what you're doing there. Okay, so it's just a format thing. Let's look at the next one. All right, so for this one, it's a little fuzzy. Let me make it smaller. There we go. For this one, you said 41 miles. That really doesn't tell us anything because it's not indicative of a direction. It doesn't tell us where she's, at. How far from the cabin did she end up? Well, that's distance, but it's not a location. So maybe the question from the book could have been written better, but what it's wanting is rectangular coordinates. And in fact, it gives you some coordinates there. It gives you polar coordinates, but it wants rectangular coordinates as the answer. So let's look at how to convert those. So we know we've got 25 miles at a heading of 20 degrees. And then we've got 50 miles at a heading of 215 degrees, right? So we can, from that, draw our right triangles. In fact, the only way to combine these is to put them in rectangular coordinates and then add them together. Right? And then we're not taking that extra step of converting them back to polar. We are converting them to rectangular so that we can add them together first. So 20 degrees, that's going to be in quadrant 1 on the coordinate system. So that's going to be about like that, maybe. That's more of a curve. Let's go straight out here. It's going to be about 20 degrees like that. This is 20 degrees, and it is a hypotenuse or a magnitude of 25 miles, right? So we don't know, this is positive R, and this is positive U. We don't know our legs of our right triangle here. So that's what we've got to find out. So we're going to do, let's do sine, because we've got SOHCAHTOA, right? Let's find U. So that would be sine because that's opposite. So the sine of 20 degrees times 25 is equal to U. And to find the cosine, we're going to do, or to find R, we're going to do cosine. So 25 times the cosine of 20 is equal to R. And that's going to give us our rectangular coordinate. So we get our calculator. We find the sine of 20. Let me go back to sine, or sine, okay, times 25. That's 8.55. We're going to do 2 decimal places. So that is going to be a positive, because it's a positive u, 8.55 u. And now we're going to do the cosine of 20. So let's get our calculator back up here. Clear that. So 20 cosine times 25. And that is 23.49, because this does not round up. So 23.49 r. And we know that we write these like this. 23.49. The x value always comes first, and that's r. And then the y value, which is u. All right, so there's the first one. The second one, we're going to do the same thing. 50 times the sine of 215 degrees is equal to u. Actually, no. It's not 215 degrees. Sorry, I forgot to draw my picture. All right, 215 is going to be in the third quadrant. So that is going to be 50 over here somewhere. That's our vector, and our hypotenuse is 50. And then from here all the way around to here, that's 215 degrees. But we can't solve a right triangle like that. So we're going to say 215 minus 180, which represents quadrant 1 and quadrant 2. And that's going to be 35 is our difference. So this theta here is 35 degrees. So that's going to be the sine of 35 is equal to u. And then the cosine, 50 times the cosine of 35 degrees is the r value for this. So now we can do that on our calculator. Clear this up. I go 35 sine times 50, and that's 28.68, because we're going to round that up. So 28.68 u. I can go ahead and put that here. And then I'm going to do the same thing for cosine here. Actually, that's going to be a negative. Sorry. That's the other benefit of, it's a negative and a negative. So this is a negative. Because it's to the left here, it's a negative r, and because it's down on the y-axis, it's a negative u. So that's part of drawing the picture that I did not do. I skipped that step, and so I did not put that in here. So that's going to be minus 28.68 u, because it is located in the third quadrant. So now we can do the same thing here. 35 cosine times 50 is going to be 40.9. We're going to round that to 6. So 40.96. 40.96, and it's going to be negative r. So negative 40.96 r. So now that they're stacked, we're going to do the math, right? And I'm going to say 23.49 minus 40.96. That's going to be negative 17.47 r. And then we'll do 8.55 minus 28.68. It's a negative 20.13. So minus 20.13 u. And we don't ask you to put it back into this polar coordinate format. You can put it in just like this. That's all we want. So this is the correct answer. Let me double check. Yes, that is the correct coordinates. So that's what we're looking for. This is where she ended up. So if we were to actually take that and put it on a coordinate system, right, here's our little coordinate. She'd be in the third quadrant because both of these are negative, and she would be whatever negative 17.47 is this way. And then whatever negative 20.13, that would be where she is. Right? And if you wanted to, I don't know why this is doing that. If you wanted to, you could find the polar coordinates so you could get her exact location, like on that little radar thing that we talked about before. So you could say 17.47 squared plus 20.13 squared is equal to c squared, and find the length or the hypotenuse of where she is. And then you could find the degree of measure of where she is, and that would tell you exactly. But we don't ask you to go through all that. You could just do this right here. Okie dokie. All right, because what actually happens in this scenario is she started here at this point, right? Wherever this is, and she went 20 miles at 20 degrees, or she went 25 miles, 20 degrees this way, here, and then from this point, she went 50 miles at 215 degrees. So 50 miles, 215, if this is 90, 180, 215 will be about like this, and she went, that's 20, then she'd be over here somewhere, which is what that looks like on our coordinate system. So that's what we did. We combined those two in rectangular, which is the only way you can really do it. We combined those two into rectangular coordinates, and that is the information that we want to put in the system. Let's look at the next problem. All right, so this problem asks us to add these two vectors together. So that's what we're going to do, just like we did in the wilderness tracker, whatever problem that we just did. So again, 30, 45, we have to know the coordinate system that it's in, which is going to be this quadrant 1 because it's 45 degrees. So that's about halfway, about like that. So that's the vector, and this is the hypotenuse, right? So we're going to make our right triangle so we can get the legs of the triangle, so we can figure out this is 45 degrees. This is up on the u, or on the y-axis, so it's a positive u, and it's to the right on the x-axis, so it's a positive r. So sine is opposite, so we're going to say 30 times the sine of 45, and I wrote 40 for some reason. 45 degrees is equal to positive u, and 30 times the cosine of 45 degrees is equal to positive r. And then we're just going to do the calculation for that. Let me pull up the calculator, and we get, for this one, we get 45 sine times 30 rounded to two places is 21.21. So 21.21 u. And then we have the cosine. So 45 cosine times 30 is 21.21, because a 45 degree angle means that this right triangle here, this is also 45 degrees, which means that it has an equal distant leg here and here. So whichever way you would flip this triangle would be the same measurement. So this one's going to be exactly the same thing that u is. And that is true for 45 degree angles. You don't even have to do the math for both of them. You could do the math for one, and you know it's the same for the other. So when we put those together, we have the r comes first because it is the x measurement, or the x point, I guess is a better word. And then we do the r, 21.21 u. Okay, so that's the x and the y, and x always comes first. So now let's do 10, 160. So we have to figure out where 10, 160 lives. So we know that it's going to be over here because 160 is more than 90 but less than 180. So it's going to be at about the 20 degree off the line mark because, let's see if we can get about 20 degrees. It'll be about right here is where it's going to be. So that's our vector, and this is 10. So if this is 90 and this is 160, then we can take 90 from 160 and we get 70. So if this is 70 and this is 90, then this is 20, right? Which we kind of already knew because we said 180 minus 160 would be 20 away from this point right here. So that's where we are. So we have a negative r because it's on this side, but it's a positive u because it's above the x-axis. So we're just going to plug in our numbers like we did before. We're going to say the hypotenuse times the sine of 20 degrees is equal to u, because that's the opposite side, and 10 times the cosine of 20 degrees is equal to a negative r, because that's where it's located. It's on the left side of the y-axis. So now we just do the calculator bit. So we do 20 degrees sine times 10, 3.42, so 3.42 u. And now we do the cosine bit, if I can remember to get the calculator part up. All right, and that's going to be 20 cosine times 10, 9.396, just going to round up to 9.4, because if you round up the 9, that's going to go to a 4, so 9.4. All right, 9.4 r, but it's negative. So we're going to put that over here. Negative 9.4, and I'm just going to give it 2 places, just so it fits, plus 3.42u. Combine those together, and we can just use our calculator because Miss Tracy is lazy right now, and I'm on vacation, so I can use my calculator if I want to. Minus 9.4, that's 11.81, so 11.81 r plus 21.21 plus 3.42, 24.63. So 24.63u, and that would be your answer. That's what we're looking for. All right, so let's look at the next problem. All right, so this one is correct. You just didn't distribute, and I did. So that would be BP, that'd be BZY or BYZ. You put it in alphabetical order like you're supposed to, that's what it would look like. And then A plus BC, A plus CB. Put in alphabetical order like we normally do, and then it'd be the same thing. You got that right, so I'm going to mark it correct. So you don't have to do anything to that one. Yay! All right, last one. See, that wasn't so bad. So we are supposed to estimate. Well, when we estimate, we want to round to 1 decimal place. That is the standard operating procedure, the standard practice for estimating. So we're going to round this to 1 decimal place. So 4.7, actually no, I take that back. Let me make sure. We're going to round it to 1 place. So that would be 5. Sorry, 1 place. Sometimes I forget. I'm old, it happens. So now that's going to be 10 to the 1, 2, 3, 4, 5, plus 5. So that'd be 27. And then that would be 8 times 10, and that'd be 6, 7. I've been helping Algebra 1 and Pre-Algebra a lot today, so sometimes I get where they are versus where you are cross-confused. So when I make a mistake like that as to where to round, that's where it is, because y'all are all at different levels. All right, so this one we would round to 10. which would round to 1, right? So first of all, let's do 10 times 10. Okay, so that would be 6. Let me redo this. If this were, we could round that up to 10,000. I'm sorry. No. I'm telling you, it's already been a long day and I'm supposed to be on vacation. Look at this. It's crazy. It's crazy. 1 million. 1 million, not 10,000. All right, so that's 6 zeros. 1 times 10 to the 6. Okay. Sometimes you just got to wrap your head around it. 1 times 10 to the 6. There we go. Now that's right. And then we're going to redo this. 5.1 doesn't round, but to 5. So we say 5 times 10. And this is 1, 2 forward. So we're going to add 2 to that. So that's going to be a negative 12. All right, now 5 times 8 is 40 times 10. 27 plus 7 is 34. 1 times 5 is 5 times 10. 6 minus 12 is negative 6. 40 divided by 5 is 8 times 10. And when I take this up here, I add 6 to it, and that is 40. That's your answer. All right, I do believe that's right. I'm going to double check. Yep, that is the right answer. 8 times 10 to the 40. So you were almost there with this right here, because if you round this up, that becomes 7.5, and then you can round 7.5 to 8. So you were close. It's just this little word here, this estimate, that throws us off. But at the level that we're at, we would estimate, we would round to one place, the ones place, right? And sometimes that means you take this right here and you go 4.7 rounds to what? Oh, well, that equals 5. So 1, 2, 3, 4, 5. Add 5. 22 plus 5 is 27, right? That's what you're doing. So fun times. Lots of math to do. But that's how you want to estimate it. If you have any other questions about what we did, just give me a holler. You're doing great. Just keep asking questions, right? Keep sending me messages. You're not bothering me, okay? I would rather spend my Christmas break helping you understand and helping you master and put this stuff in correctly than coming back second semester and being lost and frustrated and not knowing what to do. Okay? That's not what I want for you. I want you to do well, and you are too smart not to take advantage and figure it out now while you have the time. That it would just be a waste and a loss to me to see someone so intelligent and so bright when it comes to math not invest in themselves to clarify these little things from the system that throw you off. Don't let the system that we use be where you lose understanding. Don't let it stop you. All right. I would rather you work out the problem, get the right answer, and bring it to me on paper and say, look, Miss Tracy, I got this on paper. Is this right? If this is the right answer, can you please manually grade it for me? I'm happy to do that. Okay? Any problems that you can solve on paper, and I can see the steps where you solved it, so I know that you did it right and that it's you doing it, I'll give you credit for it. Every single time. So if you can't get the system to work for you or to mark it right for you and you don't understand what's going on, but you know you're getting to the right answer, come show me. And then I can show you, hey, this is what the system's looking for. This is how you need to type it in. And then I can give you credit for getting there and finding the answer. But then going forward, you know what the system is looking for. And it's less frustrating to have the system tell you it's correct than to constantly beat your head against the computer screen and be flustered. All right, I'm going to let you go. I know you want to enjoy your Christmas break. Have a good one. I hope that Santa Claus comes and visits you. If you still believe in him, I hope you believe in him, because I've told my kids, even my 20-year-old, that as long as you believe in Santa Claus, you get presents. So they lie and tell me they believe in Santa Claus. So, we just want our kids to stay young, because then that means we're not getting old either, even though we can. I'm going to quit rambling. All right. Have a great break. I love you. And I hope that you are enjoying all that this time of the year has. Bye for now.